Hey y'all, Miss Lockhart here, and I'm standing in my kitchen, alright? So, let me show you what I'm doing. Alright, so I have different states of matter, because yes, we're still talking about matter. So, in this glass right here, I have ice. Ice is a solid. As you can tell, it has a definite shape and a definite volume, right? And then I have some boiling water. And here I have two different states of matter. The water is liquid. And this gas that you're seeing, or this water vapor, that would be the gas. So right here in my kitchen, I have my three states of matter. And guess what? They all have the same chemical makeup and the same atoms because they are all water.
All right, guys, let's keep learning about matter. All right, so the essential question for today is, how do particles behave in the four states of matter? All right, so we have already learned about the composition of matter. We have learned about the properties of matter. Today, we're going to focus on the phases of matter. So by the end of this video, you will be able to describe and explain the differences between the three phases of matter. All right, states of matter. You all have learned this before, but now we're going to get into more detail. Okay, so it is important to understand the particle nature of matter. The particles that make up matter are not small bits of solid or small drops of liquid, but rather atoms and molecules. So what that means is that solid piece of ice is made up of atoms and molecules, okay? The physical properties of those atoms and molecules decide what state that object is going to be in. Okay, so why do different phases exist? The behavior of molecules determine the phase of the substance based on the property, because molecules are always in motion. You cannot see air, right? But it has molecules and atoms, and those molecules and atoms are constantly moving, even though you cannot feel them moving and you cannot see them moving just by looking into space. Okay, so matter is atoms and molecules that are always in motion and always bumping into each other, hence the bumper car picture on the last slide. The speed and attraction of particles determines the states of matter, and you already know the three states of matter that are always talked about, which is a solid, a liquid, and a gas. And then there is a fourth state of matter called plasma, and it usually occurs at very, very high temperatures. So think about the sun, because the sun has plasma. All right, imagine dropping a marble into a bottle, okay? When you drop the marble into a bottle, does anything happen to the shape or size of that marble? No. Would the shape or size of the marble change if you put it into a larger bottle? No. Even in a bottle, the marble keeps its original shape and volume because it is a solid. And that is what definite means. No matter what container you put a substance in, if it has a definite shape and a definite volume, it will stay the same no matter the container. All right, so a solid is the state of matter that has a definite shape and volume, meaning you put a solid into a container, it's going to stay the same. The particles of a substance in a solid state are very close together, and there is a strong attraction between those particles. The particles in a solid do move, but they do not move fast enough to overcome the attraction between them. And the way they move is that they vibrate in place. As you can see in the diagram, little vibration happening. If you've ever thought about what happens when you beat on a desk, because a desk is solid, you have some type of sound, and the reason why is because of vibration. So you beat on a desk, like vibrations are occurring, okay? Particles in a solid have less energy than particles in other states. And when you see energy in science class, I want you to think of heat. When you see energy in science class, I want you to think of heat. All right. What do you think would change about soda if you poured it from a can into a glass? Would the volume of the soda be different? Would the soda taste different? Okay, a liquid is the state of matter that has a definite volume, but no definite shape. Meaning, if you were to pour a can of soda into a glass, the volume would stay the same. The amount of space would stay the same, but the shape would change because liquids take whatever shape of the container they are in. Although liquids can change shape, the volume stays the same. Particles in a liquid move fast enough to overcome some of the attractions between them, meaning they slide past each other until the liquid takes the shape of its container. Once again, in a liquid, the particles slide past each other. The particles in a liquid have even more energy than particles in a solid. Checking for understanding. How is the molecular movement of particles in a liquid similar to the particles in a solid? How are they different? Okay, a gas is the state of matter that has no definite shape or volume. The particles of a gas move quickly so they can break away completely from one another. The amount of empty space between gas particles can change. The particles of a gas have less attraction between them than do particles of the same substance in a solid or liquid state. The particles of a gas have more energy than the particles of a liquid or a solid. You should be seeing a trend. Solids have less energy, liquids have a little more energy, and then gas has even more energy. The energy increases as you change states of matter from a solid to a liquid to a gas. Check for understanding. How is the molecular movement of particles in a gas similar to the particles in a liquid? How are they different? If we were to compare the liquid and gas state, and this is an element, bromine, as you can tell, the top is gas, the bottom is liquid. Look what's happening with those particles. Remember, gas particles move wildly around. They just bounce off of their container walls and off of each other, while particles in a liquid slide past each other. Now, which one has more energy, the gas or the liquid? We cannot forget about plasma. The fourth state of matter is plasma. It has the highest energy of all the states of matter. The energy not only exceeds the attractive forces among molecules, but also exceeds the attractive forces that hold atoms together. As a result, molecules of plasma are broken down into a cloud of protons, neutrons, and electrons that all move and function together. Don't worry, we'll learn about those. Examples of plasma are lightning, fire, neon lights, northern lights, and stars. Check for understanding. Which state of matter has particles that can slide past one another, but still has a fixed volume? If you said liquid, you're correct. All right, let's wrap this up. We classify states of matter based on how fast the molecules move. Molecules move faster as they absorb more energy, heat. All right. In a solid, molecules move slow and vibrate in place. They have the least amount of energy. In a liquid, particles move faster than solids and overcome some attraction. They have a little more energy. In a gas, particles move fast and overcome all of the attraction. They have a little more energy. And in a plasma, they move incredibly fast and break apart. They have the most energy. And that's it for how we classify phases in the states of matter.